Randy or someone else, if you can just make sure that he if he has slides for his lightning talk, gets them into the back, the folks in the back, if you see him before. So, yeah. Just a couple of announcements. First of all, I'd like to thank our sponsor, TELUS, for the social last night. That was a lot of fun going to the TELUS World of Science. So I had a good time. I hope everyone else did. Thank you very much. Thanks also to our sponsors for the breakfast and all of the socials that we got to go on. This was another great, if rather tiring NANOG with all the socials to go to. But I think we all had a lot of fun. So I'd just like to, one more round of applause for all the socials and for our sponsors. Thank you. Just a couple of announcements before we get started. I know this kind of goes without saying, but let's try to remember to silence our devices, computers, cell phones, smartphones, all those devices that make noise. Please try to silence them. It's very distracting up here for the speakers. So please, if you could do that, it would be really nice for all of us. And I think that's about it in the way of announcements. So I'm going to bring up our next speaker, and that is that's Paul Vinciguerra, and he's doing a talk on LISP, this sort of follow-on to where we left off yesterday. It's called Our Customers Are Deploying LISP. See how it impacts you as a service provider. So go ahead, Paul.
Paul Vinciguerra with Vinci Consulting, and I wanted to talk to you today about what our customers are doing. They're deploying LISP. After speaking to a bunch of people here, I think the mindset is that LISP is still something that's experimental and it's something that's not really ready, but I can tell you customers are using it today, and you should know how it works and how it impacts your networks. These aren't my slides. These are my old. These are my very old slides.
Okay, I'm sorry.
These are all the things that you have to take out. These pages and things.
See if you can forward through them. Is the content the same?
No, not at all.
Sorry about that, folks. We're just having a little bit of issue with the slides right now. We'll get this fixed right away.
Yep. Okay.
All
Yeah,
right, go ahead, Paul.
All right. So I wanted to talk about our customers are deploying LISP today, but really it's your customers are deploying it because what happens with LISP is we wind up using your service provider networks as transport. So the question is, why do we even get involved and deploy this? And as you know, everyone's customers are moving to the cloud. I hate the cloud, the term the cloud. It doesn't really mean anything. They want high availability. They're looking for extra ways to increase their bandwidth to get them to the cloud, and they're looking for ways to not lose individual links anymore. They're expecting availability benefits beyond what they can get today with BGP. That's why we're starting to see more and more interest in people deploying LISP. Typically what happens today is our customers take on the deployment on their own. Typically, they have their enterprise edge and they have their data center someplace else, and they're running BGP multi-homing across them, no LISP at all. So first thing they do is they go out and they'll do upgrades to install the XTRs, and they'll add map servers and map resolvers so that they can start getting the fundamental benefits of LISP. At this point, they have traffic engineering capabilities that they can do very simple load balancing across the links. They can start using their excess capacity, as opposed to typically with BGP, they're in an active, passive role. Once you've gotten to that point, they typically want to start adding in address mobility. LISP allows for individual addresses to be moved anywhere. So by adding in the PXTR functions, addresses can turn around and be moved from one location to another location. So it's much simpler for all of this infrastructure to be put external, being deployed in a service provider area, as opposed to the enterprise doing it themselves. When the enterprise then wants to do LISP, all that they do is their upgrade for their XTRs. So, as I was saying earlier, the clients can do everything, or the XTRs, the customer's data center and their remote offices and remote locations. There are opportunities for running LISP, for multiple circuits, for doing high availability and additional redundancy. On the data center side, whether it's a customer data center or it's a service provider who's providing hosted data center services, there's an opportunity for providing higher availability and simpler deployment. And the service provider itself can get involved in either in the infrastructure or at the edges for the XTRs. Okay. Is there LISP on your network today? I think the answer to that you're going to see is yes. It's typically tunneled in UDP. It runs over ports 4342 and 4341, control and data planes. And if we go to one of our routers, we'll see, yes, you'll find LISP on your networks. The thing that's interesting here is LISP tunneling is done in UDP. It's not done in GRE, which is what I think everybody's used to. Create a GRE tunnel between 2 points, and the tunnel's up. One of the problems with GRE is everything's flowing over one path. When it's UDP, you have options of distributing the data per flow. So if we look at the LISP data plane, before we initially deployed LISP, our traffic share was running 80-1. We had one link that was hot and one that was standby. And after we deployed it, we went to 8-1 the day we deployed it in terms of our incoming traffic. So the question was, why didn't we get 1-1? We were configured to be 1-1, and it wasn't what we were seeing. So digging down further, it turned into we had heavy IPsec traffic flows that it was turning into. We had one source and one destination. It was one flow. Everything took that one path. The thing that turned out to be interesting, if we come and we look at it, this is all Protocol 32, Protocol 50 IPsec. The Cisco implementation goes and maps the SPIs as source and destination ports so that we get load balancing per SPI in a VPN. If you wanted to do better traffic engineering, you could break up how you define your interesting traffic if you really had a need for balancing it. So coming back to production list volume, and some of the earlier feedback I was getting from people is that this is something that's not, it's not really out there, it's not prevalent. The LISP beta network that's out there, what do we do? Their PXTR, which is the point in which the LISP and non-LISP traffic interact, has traffic on it. The term that they use is beta. It's been beta for 4 years, 5 years now. I think it's time that they need to up it to, that's where they're doing their innovation, in that this network is always up. When someone says beta to me, it's something that's there, and when they're making changes, they bring everything down. I know people who use this network all the time, and this network is always available. So in terms of people who are using this, NJ Edge is a nonprofit consortium of colleges in the New Jersey area, and they're sustaining LISP traffic every day. They sustained 2 gig streams all the time. There's a good amount of LISP traffic out there. So this is where I think things start getting interesting for everyone here, is what does this all mean to you? We were talking yesterday about different components, PXTRs and XTRs and all these other terms, but at some point they need to be brought down to how it's going to impact how you run your networks. So you're a single provider who's providing transit for a customer. You're supporting their headquarters in a data center, and they're both running LISP. Now, their traffic flows just flow back and forth the same as it does if they weren't running LISP, except for the fact that their addresses are not your addresses. They're addresses that have been allocated as EIDs. So if you're also providing transit for another customer who's not running a LISP, what happens when let's see, when your customer here wants to speak to this customer, they have no reference for what their EID addresses are. So what happens is they wind up going to a PXTR, which is located someplace, and most likely it's not on your network. So their traffic flows flow to the PXTR that does the encapsulation and then back to the 2 end sites. And this is what happens whenever you're going from a LISP space to a non-LISP space. So you may think that because your 3 customers are all on your backbone and you have plenty of capacity, they may not necessarily be communicating in the means that you think. Okay. So if we look at a specific traffic flow for someone who's in an EID space, somebody who's using LISP addresses, they're going in there, they're pulling down looks like a 5 meg stream here. What actually happens is they wind up sending the data. It goes to the PXTR. It actually goes through the PXTR, gets encapsulated, and then gets passed down to the destination. And it kind of flows like this. So when the PXTRs are located outside of your backbone, you wind up having to transit out and transit back. So there are a number of cases for the way LISP flows. If you're not doing LISP at all and you're just using your RLOC addresses, is basic routing from the outside of the router to whatever other device you're connecting to. It's global routing. If you're going from a global address to an EID or a LISP address, and the EID is in our map server, you're going to flow to the PITR, and then from the PITR, you're going to be LISP encapsulated to get to the final destination. If you're going from a LISP address to a non-LISP address, you're going to go through the PETR. In the case of the NLISP devices behind the network that's RPF protected, or if you're doing you deployed LISP because you want to do IPv6 over IPv4. So in the case where you're going EID to EID, and the EIDs are known by the map server, that was the case that we were talking about earlier between the two top buildings. The traffic just flows directly across your network. There's no transition. And in the same situation where you're going EID to EID, but they're two separate islands, this is by far the most complex path, because the traffic goes from my customer's EID to my PETR, finds the other island's PITR, travels to that, and then he tunnels it back to his customer. So even when the two devices are sitting next to each other, they'll bounce all over ISPs. So this is what the discussion yesterday was about. By using the DDT, the worst case we were just talking about is addressed. So the DDT lets us turn around and do this lookup across different islands. So in the case where we're doing EID to EID and I don't know about the other EIDs in my map server, we wind up going through a 3-step process. By introducing a DDT, we can go directly from a LISP-enabled router to somebody else's LISP-enabled router. The DDT is the glue that starts bringing all these environments together to lower the impact of LISP on your networks. Okay, so one of the tools that we have for DDT, and I think this was demonstrated in the slides yesterday where you saw the ratcheting effect, where they went up to the root and they started coming down to find where the locations were. If we go in, this is a query that we did against our DDT route to look in our address space. And what we can see is our address space that we were looking at, the 199.119.75.0, is available through an IPv4 and an IPv6 address. And then it brings us directly down to the map server that can handle that. If we go and we use our same DDT route to look for addresses that are in the LISP beta network, you will see that they go through a number of hops. First, they go through and they look at 153.16.00. They come up, they find a more specific route for a/19. And then they finally stop it at the /24, and they give us the information to go and find that. And that was what you saw yesterday in the slides where they went and they kind of walked the tree until they found their source, and then they would just, from then on, cache at that final destination. Okay, so when we were deploying this, we had a couple of concerns and a couple of operational issues that we came across. The first one was MTUs. Because we're doing encapsulation, we were concerned about what is that going to do for people who are stuck at 1,500 MTU size, people who are PPOE or encapsulated in other tunneling protocols. What we found out that was interesting is that with the Cisco implementation, it actually does a PMTU check and does the adjustments. It will go figure out what's the right size for the packets and adjust along the way. So we were concerned that going to a PXTR and coming back was going to cause us latency. We have not seen that latency was a problem. And the actual biggest problem that we came across was the fact that the way LISP works is we do basically routing by RLOC, which we do routing by your router's upstream address, the address that you normally give us on a /32. Now what's happening in the New York area, service providers are doing carrier grade NAT. The uplink address is a private address. Because it's a private address, we can't actually route to it. So this has been a case where we haven't been able to deploy LISP. And I think these are the same resources you saw yesterday. There's a number of open solutions, open sites that are available that explain LISP and DDT and all the things that are being done out there. I don't know, are there any questions?
Any questions? Microphones are open.